Actually, we are going to discuss about Lami's theorem in this section, and you see, this is going to be a very important part to understand the theorem itself, not about the derivative. I mean, the result like P by sine A is equal to Q by sine R, not like that. So let us try to understand what it means. Let us say that there is an object here. So because it is going to get cluttered little bit, so please follow this right from the beginning to the end, and before even you attempt to change, let's say just put aside 5 to 6 minutes so that you will understand it or comprehend it fully. Let us say there is an object at this point, and you're going to apply a set of 3 forces so that the object is in equilibrium. Let's say first our force F1 is there, so this F1 is acting in this direction. Okay, and this is our force F1. Let me name it here, F1. And we are going to apply another force F2. It's not only about forces. Once you prove this for force, which is nothing but rate of change of velocity, which is nothing but mass into acceleration, where acceleration is nothing but rate of change of velocity. If you work this out for force, it is going to work this out for, it is going to be working out for velocity also. And there is the next force acting in this direction. Okay, so now under the action of these two forces, this object cannot be at rest. This force is here, this force is here. This will go in which way? The sum of these two forces is the resultant force on this object. So what is the sum of these two forces? Let us try to find the sum of these two forces. Let us name this force F2. So this is our force F2. Now what is the resultant force? How do you find the resultant force? In order to find the resultant force, what you are supposed to do is, you have to take the tail of one vector, keep it on the head of the other vector, and now from the tail of one vector to the head of the final vector is giving you the resultant velocity. So similarly here for the resultant force you have to be like that. So what you do is this. From this, so the resultant of force F1 and F2 is from this tail to this head. Now this is the resultant force. Now in order to stop this object from moving, to keep this object at rest, equivalent to this force, because the effect of these two forces, this force, you have to apply a force which is exactly equal to this force but in the opposite direction. So let us do the same. One second. Exactly this force. Okay, but act in the opposite direction. So exactly opposite. Now this force acting on this object will keep it at rest. Okay, now let us try to understand, like this is the third force F3, which is going to compensate F1 and F2. Let us name it F3. If the angle between F3 and F1 and F3 and F2, we have to give some angles, right? So the angle between the other two forces, if F1 is one force, the angle between other two forces is, let us call it alpha. If this is alpha, you know that this angle is 180 minus alpha. Suppose this is F2, the opposite angle, let us call it beta. If this is beta, you know this angle is beta, so these two are parallel because this force is only we have taken here. So this line, you know, if this is beta, angle between these two will be beta. We are going to draw an understanding line over here using red. So this line and these two are parallel, and this is a straight line. If this is beta, this is also going to be beta. So this is beta. Then this is going to be 180 minus beta. This is F1, that means this magnitude is F1. This is F3, this magnitude is also F3. And the next one, the F3 is this force, the angle between F2 and F1, let us say this angle is F2 and F1, let us call it gamma. If the angle between these two is gamma, then this line and this line are parallel. This straight line we will try to extend it. When you extend this line, see this straight line, this angle is gamma, means this angle is also gamma. So this angle is gamma. Then this angle will be out of 180, this gamma is gone, means 180 minus gamma. So this two forces F1 and this is F3 and this force is F2. Now that you have a triangle and the length of the triangle, these are forces, right? So the length is proportional to magnitude of the force. So this length is F2. We know from the sine rule that opposite angle to the side ratios are same. So sine angle F2 by sine and F3 by sine 180 minus gamma and F1 by sine 180 minus alpha. So let us write like F1 by F1's opposite angle is 180 minus alpha. So sine of 180 minus alpha, and this is F2. F2's opposite angle is 180 minus beta. So F2 by sine of 180 minus beta, and F3 opposite is 180 minus gamma. So F3 by sine of 180 minus gamma. So sine of 180 plus or minus theta is sine theta. So sine of 180 minus alpha is sine alpha. And F2 by sine of 180 minus beta is sine beta. And F3 is sine of 180 minus gamma is sine gamma. So the point is F1 by sine theta 1 equal to F2 by sine theta 2 equal to F3 by sine theta 3. So to give you a clarification, I am going to draw again once more. Suppose this is one force F1, this is F2 and this is F3. So these three forces are acting. Let's say it is F1, this angle is alpha, this is F2, this angle is beta, this is F3, this angle is gamma, then F1 by sine alpha equal to F2 by sine beta equal to F3 by sine gamma. This is what Lami's theorem. Lami's theorem is for three forces or three vectors are in that form the sides of the triangle. So this is applicable only when three vectors form the sides of the triangle.